Hello, this is another in the series of videos addressing the installation of Cisco Modeling Labs version 1.2. This presents the process of installing Cisco Modeling Labs on a bare metal server without the underlying ESXi hypervisor. First, let's take a look at our agenda. We will look at the necessary prerequisites to installing a bare metal deployment of Cisco Modeling Labs. We will then examine what needs to be performed as to prepare our server for the installation process. With the server preparations completed, we will then boot the ISO distribution file and answer the queries and prompts from the installation wizard. This will format and initialize the server's internal storage disk and transfer the Cisco Modeling Labs software components to the specified volume. Following the software transfer, some additional adaptations will be necessary depending on the compute platform details and the operating environment. Our final step will be the customization of the Cisco Modeling Labs server and insertion of its licensing file. Before beginning the installation process, let's ensure we have what's needed. First, the ISO distribution file must have been downloaded and verified against its provided MD5 checksum value. The process to do this is already covered in another video installing CML 1.2, video number 2, and won't be repeated here. As there are a wide variety of available server products, Cisco Modeling Labs is only tested against a limited set of those options. Because the software interacts directly against the hardware, it's important to utilize servers on which Cisco Modeling Labs has been explicitly tested and validated. This ensures predictable behavior and assures Cisco's support engineers the ability to deliver customer assistance. For low to medium-sized simulations, the dual-socket Cisco UCS C220 M3 and M4 servers offer good performance within a minimal rack space. When CPU core requirements exceed what can be achieved in a dual-socket server, the current Cisco UCS C460 M4 server is recommended. The older Cisco UCS C420 M3 and C460 M3 servers are also viable platforms on which Cisco Modeling Labs may be run. It is best to perform the software installation process with locally attached KVM devices. A monitor resolution mismatch impedes the ability to remotely access the server's console. This will be corrected as one of the post-install steps. Cisco Modeling Labs is a CPU-intensive application that requires all of the active virtual machines to be running in resident RAM resources. To determine the appropriate server platform, a capacity calculator is available via www.cisco.com. Based on the projected numbers and types of virtualized network devices and hosts, the capacity calculator will return the recommended quantity of CPU cores and required DRAM. These values can be used to select the appropriate server. Platform recommendations minimally call for a 250 GB internal storage disk. This will be used for the base Ubuntu server operating system and KVM hypervisor, the OpenStack orchestration software, and other Cisco proprietary extensions. The resultant file system will also contain the various virtual machine images used to spin up the selected network devices within simulations. Larger drives are acceptable, as well as RAID configurations. Cisco Modeling Labs provides several methods to interconnect the virtualized network nodes with external real devices. In addition to the platform management SIMC port, the application must see 5 network interfaces to install correctly. The 2 motherboard-based NICs should be augmented with either a quad-port PCI Express or MLOM expansion adapter. Beginning the installation process, we attach the keyboard, mouse, and monitor to the server. This can be via the dedicated connectors at the rear of the server or using the adapter dongle for front-facing connection. With the console devices attached, power up the server. As the server performs its power-on self-tests, scrolling messages allow the startup to be halted and basic attributes configured. This includes the Cisco Integrated Management Controller or SIMC interface used to manage the server, the BIOS settings, and depending on what's fitted, the disk storage adapter configuration utility. Generally, the first step is to set the SIMC interface details. Once configured, the SIMC interface provides an alternative method to set the BIOS and storage configurations. Details for this stage should refer to the selected server's respective documentation for product-specific details. Pointing a browser at the configured address, we can log into the SIMC using the default credentials. Depending on our server's installed HBA, we can set up our internal storage. This server is fitted with the hardware-based RAID module, so we will configure a RAID 0 volume. This is done by selecting Create Virtual Drive from unused physical drives within the Controller Info tab. Choose the desired RAID level, and based on that choice, check the appropriate physical drive options, and click the right caret button as to move into the drive groups list. Enter the desired virtual drive name, and then click the Create Virtual Drive button. We can now see the available storage resource and are now ready to load the ISO image. With the server prepared, we are now ready to deploy the software. Using the CMC virtual devices, we then mount and subsequently boot the ISO distribution file. This will load an installer that provides a couple of options to install the software. The installation process is performed by an installation wizard that sets up the operating system and then transfers the Cisco Modeling Labs files to the file system. Once the transfer process has completed, we make the necessary adjustments to the network interfaces. This may entail editing the device name learned during the install or applying dummy references should the server not have the required numbers of NICs. By default, the installed system will employ DHCP to acquire its primary IP address. It is recommended that a static IP address is assigned. Within the Actions pane, click the Launch KVM Console link. This will start the Java-based remote console. Accept the security warnings, and the virtual console window will be presented. Using the command banner, we activate the virtual devices and mount the virtual CD/DVD resource. This allows us to map to the previously downloaded and verified ISO distribution file located on your workstation or shared storage. If necessary, use the Browse button to locate the ISO file. With the mapping complete, use the command banner to trigger a reboot. Skipping through the server self-test and boot cycle, the installer is loaded, presenting the depicted splash screen. We're only concerned with the first two options. The Live option will load the Cisco Modeling Labs operating system directly from the ISO file. Once the boot up is complete, you must log in using the default credentials. This will present the console desktop. The Install System to HDD icon will load the install wizard that facilitates the application deployment. The Install option will skip the operating system boot and directly invoke the Install wizard. Our demo will use the first option, Live Deployment. The underlying Ubuntu will boot to memory. Once it completes, we are presented with the login splash screen. If using a remote console, you will experience a video capture fault. This is why we recommend directly attached console devices during the installation phase. We will apply a fix to this after the software installation. When presented with the Cisco Modeling Labs console desktop, double-click the Install System to HDD icon. This will load the install wizard, which will present a sequence of queries to which the responses will customize the initial software installation onto the server. We'll first specify the language as English. Next, we confirm the server has the minimal requisite local storage and operational network interface. Do not enable automatic software updates. Cisco Modeling Labs is a tested integration, and introducing non-verified components risks breaking the application. For the installation type, we want to erase the disk and perform a fresh install. Enabling encryption is not recommended. Logical volume management should be selected for the installation. If needed, the something else allows for manual disk partitioning and custom volume dimensions. However, it is recommended to use the default partitioning. Clicking Install Now will trigger a pop-up window displaying the partitioning details. Accepting these, we can identify our time zone, followed by selecting our keyboard format. We are then presented with the Who Are You page. There's no particular restriction on the Your Name field. Use whatever you prefer. However, we must use CML in lowercase as the host name. If desired, it can be changed later, but the installation will fail if a different host name is used during this phase. We will use the default user and password strings, but these can be set in accordance with your installation preferences. By default, a password should be required to log in, and the home folder should not be encrypted. Clicking the Continue button will initiate the installation process. The local disk will be partitioned and formatted as per the wizard settings, and the Cisco Modeling Lab software will be transferred to the server's file system. This will take some time to complete the transfer, so now is a good time to break for lunch or other task. Expect about 45 minutes for the installation scripts to complete. Upon getting the notification, clicking the Restart Now button will disengage the virtually mounted ISO file and reboot to the local storage volume. Upon the system reboot and subsequent login, we are again presented with the console desktop. By double-clicking the IP address desktop icon, an Xterm console window is presented showing the DHCP acquired address for the ETH0, the primary management interface for the server. At this point, we need to verify the presence of the other necessary interfaces. Typing the command ifconfig pipe grep eth will report the interfaces using the prefix expected by Cisco Modeling Labs. Our server only presents the two interfaces associated with our motherboard. The IP link show command indicates more interfaces are actually present. Applying a filter, IP link show pipe grep em shows our PCI ports were discovered with the em prefix. This will prevent their being recognized by the application, leading to a failed rehosting procedure, and must be corrected before moving on. To fix this, we use a text editor to modify the /etc/default/grub file. Our example uses the nano editor. As documented in the installation and admin guide, make the demonstrated edits to reference the BIOS device name equals 0. We save the edits and exit the editor. We then update the bootloader with the sudo update grub command, followed by a reboot. Once the system completes the reboot cycle, reestablish a session with the server's console. Repeating the command ifconfig pipe grep eth should now report the 5 interfaces correctly. If the server is not fitted with a quad port Ethernet adapter, then dummy interfaces must be prepared. Refer to the installation and admin guide for the necessary step to add these interfaces. With the correct number of interfaces reporting, we can now set a static IP address for the primary interface. Using a text editor, open the /etc/network/interfaces file. Scroll down to the ETH0 settings, then replace the DHCP reference with static. Then add lines specifying the host address, the network mask, and the default gateway. It is necessary to have 2 working DNS references. The default entries point to Google's public resource. These should be updated to an internal DNS server if the public ones are not accessible. Save the edits, then exit the editor. The server will need to be rebooted again to recognize the changed address. We have a few remaining steps to complete this phase of the installation. We can now fix the virtual console resolution mismatch that has prevented remote management via the SIMC interface. While temporary access can be set via the console's graphical user interface after the login process, the setting is only good for the duration of the session and still requires the directly attached keyboard, mouse, and video to effect. To configure a persistent resolution, a shell script setting the video resolution to 1024 by 768 is referenced during the boot up sequence. Once access via the virtual console is assured, we then enable access to the console via the primary management interface. This will require resetting the SSH keys. A final reboot is necessary, after which we then perform a couple of health checks to verify proper operation before accessing the user workspace management pages. Remote management via the SIMC interface may be enabled locally through the Desktop Manager GUI. However, this still requires directly attached KVM devices, and the setting is maintained only for the duration of that session. To enable a persistent solution, we apply a shell script during the boot up process that matches the monitor resolution to a format compatible with the SIMC's virtual KVM. This can be performed via the local console or remotely via the SIMC interface. We will use the latter in our demonstration. Using the virtual KVM macros, issue a Ctrl-Alt-F2 followed by a carriage return. This will switch to CLI mode. Log in with the credentials specified in the install wizard. Using a text editor, open the Desktop Manager configuration file. Add a line that references a video resolution setting script. We'll call it lightdm_cm.sh. Save the file and exit the editor. Create a new file in the Desktop Manager directory using the previously set name. In this file, insert the indicated lines that call for the X window resolution utility and set the default mode for 1024 by 768. Save the file and exit the editor. Set the newly created file as executable with the chmod command, then reboot the server. To enable remote logins via Cisco Modeling Lab's primary management interface, the SSH key must be reset. Logging back into the console, open an xterm session. Enter the following commands: sudo ssh-keygen-A, then sudo service ssh restart. We then perform some basic health checks. The sudo kvm-ok verifies the proper CPU options are set and the KVM hypervisor is working. The Nova service list validates the compute aspects of OpenStack are in service. And the Neutron agent list confirms the networking elements of OpenStack are working. This concludes the software installation process for a bare metal deployment. The next steps to customize the server are performed using the User Workspace Management interface. That topic is covered in another video, Installing CML 1.2, video number 5.